Hello and welcome to Lesson 8 in Unit Number 1 Linear Systems in our Grade 10 Academic Math class. This is Applications of Linear Systems Part A. I don't actually think there's a Part B now that I read that, so it's just Applications of Linear Systems. So in our last lesson, we learned how to set up word problems by having let statements and creating the equations from the words in the word problem. Today we're going to go all the way through. We're going to do that initial setup again, and now we are going to complete the actual question by doing the math using either substitution or elimination to solve. Let's just jump in. Again, as I mentioned in the last lesson, we're going to be focusing on three types of word problems. The first one we're going to look at here is relative value reasoning problems, or the number problems. Let's jump right in. So it says the sum of two numbers is 280. One number exceeds the other by 26. What are the two numbers? So right off the bat, and I've already sort of cheated and put this in, we need our let statements. In number problems, we're typically talking about just two numbers. So you can say let x represent the first number and let y represent the second number. And now we need to make some equations. So I'm going to change up my color scheme here a little bit. Okay, so the first equation, the sum of two numbers is 280. So let's write that down. It would be the sum, so we're talking about adding, of two numbers is 280, and that's our equation number one. Second equation is a little trickier. It says one number exceeds the other by 26. So it means that either x or y is 26 numbers larger than the other one. So we can write this in a couple of different ways, but why don't we say that if we've got x, we can say that if we were to add 26 to it, it would be, if we add 26 to y, it will then become equal to x. That works. You could write it the other way. You could say y equals x plus 26. It doesn't really matter. Okay, so let's go through now and we'll solve. So looking at these equations, what is the best method here for solving? It's going to be substitution because we've already got a nicely isolated variable right here. So let's just jump right in. We are going to sub x, let's sub 2 into 1. I think we'll take care of it. So instead of an x, we're going to substitute in a value known to be equal to x, which is y plus 26. And there's the original y and the original 280. There we go. We have y plus 26 plus y, so let's gather together our like terms. So we have 2y's plus 26 is going to equal 280. Let's transpose 26 to the other side to isolate our variable term. We are going to then, subtract 26 from both sides. 2y then is equal to, what's that going to be, 254? I think, is that right? Yep. All right, and now we're going to isolate just the variable by dividing both sides by 2. We then have y equals, so what's that going to be, 127, I think? I hope. 127. Yep, that looks good. Okay, so we have 127 for y, and now we need to go get the other number. So we are going to sub y equals 127 into either one, it doesn't really matter. Which one was the easiest looking? Actually, I think the second one. I think number 2 looked pretty good. X is already isolated. So we then have x equal to 127 plus 26, I think it was. Y plus 26, perfect. And then we've got x equal to, so let's add those up. That's a 3, that's a 5, that's a 1, if I did that right. So 153. So we have our solution then to write out. Therefore, the two numbers are 127 and 153. There we go. And again, you don't have to do checks in questions like this, but I'm going to do it anyway. Just jump off over here to the side. So let's try one of these equations. We know that when we add these two numbers together, we should get it equal to 280. So we have our 153 and our 127. If we were to add those together, we get, that's 0, carry the 1, 7, 8, and we get 280 equal to 280. Again, this is just a little proof of concept. It's nothing fancy, nothing even really formal. I guess I could have set it up like it's a formal check, but I just wanted to do a quick little one in my head. And there you go. So this is the first type of word problem we're going to be tackling. It's called relative value reasoning problems. The next one down the line is going to be break-even problems. So we're going to tackle this one as well, and I think we'll just do the third one all by itself since that's an age problem. So let's look at this. A vacation package to Barbados costs $500 for the flight and $250 per day at the resort. A similar package to Cuba costs $1,500 for the flight and $125 per day at the resort. If the two packages cost the same amount, how long was the vacation? So we know that the two variables that they've articulated here in the question, and I'm going to grab my highlighter, is when did the two packages cost the same, and how long is that? So let's let X represent the vacation length, and that's going to be in days. Vacation length in days. And let's let Y represent the vacation cost. And that will be in dollars. In dollars. All right, so we're going to create a couple of equations here. The equations will be for Barbados. We know that it costs $500 for the flight, and that's fixed. And then we have $250 per day. So let's write that out. We have then the cost, which is Y, is equal to that original $500 for the flight plus, what was it, $250? $250 for however many days the vacation is. We're going to do something similar for Cuba. Cuba is going to have, a cost of, the flight was $1,500, but it was only $125 times however many days the vacation is. So we're looking for the day that the two packages cost the same. So that's a break-even problem, which you can see is the title of this type of problem. And it's set up, again, perfectly for substitution. We already have two beautifully isolated variables with coefficients of 1. So we are just going to literally sub 1 into 2. So we're going to sub 1 into 2, and that's going to give us 500 plus 250x equals 1,500 plus 125x. We've just set these two equations equal to each other. Let's do a little bit of moving around to get all the variable terms on the same side and all the constant terms on the other. So let's bring constant terms over here. In order to do that, we are going to subtract 500 from both sides. Similarly, I'm going to bring 125x over to the other side by subtracting 125x. So what do we have? Well, we have 250x minus 125x. That's 125x is left. And we have 1,500 losing 500. That's going to be 1,000 remaining. We're going to isolate our variable by dividing both sides by 125. X is then equal to, so 125 into 1,000, that's going to be 8. So we have it right here. So that's what the question was asking us. X, as you recall from our defining of our variables, is the number of days of the vacation. And that's what the question was asking. How long was the vacation when the price was the same? So we don't actually have to go and solve for Y. We don't need to know what the identical cost was for both vacations. All it was asking for was the day. So let's just do what they've asked. Therefore, the length of the vacation is 8 days when the cost is the same for both. All right, there we go. There is our therefore statement. Rock and roll. So again, be mindful of what you're being asked to find in the question. Again, pretty straightforward setup here. The nice thing about break-even problems is they typically get set up like this, where you've got y equals something and y equals something. Substitution's the most straightforward way to go. Go get the pieces of information you need and get a therefore statement on it. So that's the end of this first part. In second part, we're going to go after age problems, which are the trickiest ones. We're going to do one of those, and you'll be off to the homework, and then off to the assessment. This is the last lesson in unit number 1. So good luck, or I guess not good luck yet. I'll see you in part number 2.